Hi, this is Instructional, and this is my instructional video for test 2, number 4 for Physics 2, or Physics 1, sorry. This basic question is, there is two boxes stacked on top of each other being pulled up and over a hill that generally resembles a semicircle. And the first part of the question, is asked to determine the magnitude and direction of the instantaneous perpendicular momentum for the top block at the instant the block is at the top of the hill. So there's a pretty general equation that applies to this, which is just mv squared over r. So since it's asking for the top block and the magnitude of it is m2, which is the top block, the magnitude of the velocity squared over r, which is the radius of the hill, which is mimicking a semicircle. And the direction is in vector form 0 because it's pointing straight down. So nothing in the x component, nothing in the z component, only -1 in the y component because it's pointing straight down, where positive y is straight up. So that's pretty much it for the first question. The second part, which is identify the forces acting on the top block and sketch a corresponding force diagram. That part is pretty straightforward also. Pointing downwards is force due to gravity, which is m2g. Pointing upwards is the normal force, which is being acted upon by the block below it, which is block with the mass 1. And because the entire two blocks are moving to the right, friction is actually acting on mass 2, the top block, towards the right. And those are the only three forces acting on that box. So that's part B. Now comes to the stuff that I started missing, which now I understand, but at the time not so much. Part C asks, determine the magnitude and direction of the perpendicular component of the force the bottom block exerts on the top block. So basically the way I've learned to go about it is, it's basically the magnitude of the force net, perpendicular force net is equal to mv squared over r. And F net perpendicular is made up of two other forces, normal force and force due to gravity. Since normal force is acting upward, that one is positive, and force due to gravity is acting downwards, it's negative. So it is the magnitude of normal force minus the magnitude of force due to gravity equals negative mv squared over r. That makes it so that when you solve for normal force, which is the force the bottom block exerts on the top block, it will make it mg minus mv squared over r, which is basically the magnitude of that part. And the direction of this, since it's straight up, it's pretty simple. X component is 0, y component is 1 because it's directly up, and z component is 0 because it's just acting directly up. And last but not least, part D is determine the magnitude and direction of the parallel component of the force the bottom block exerts on the top block. So because we solved for the normal force in the previous section, solving for friction, which is the only force which can be seen in the force body or free body diagram, is friction. Friction is the only one in the parallel component, therefore F net parallel equals friction, basically. And friction, as we've learned before, is mu times normal force. So basically what we do is take the answer you got in the previous section, which was mg minus mv squared over r, and plug that in for friction. So F net parallel will then equal mu times Fn, which Fn is mg minus mv squared over r. So then the final answer becomes mu times mg minus mu times mv squared over r. And that is your magnitude of your force net parallel. And the direction of this is also fairly simple. Because it's at the very top of the hill, there is no y component, and since it's only pretty much acting in those two x and y, z is obviously 0. And velocity is always perpendicular to this component is always perpendicular, obviously, to the other one since it's parallel. And so the x component is just 1. So the vector form would be 1, 0, 0. I hope this helps for anyone that actually listens to it. My problem was that I just overthought it, where I should have just kind of seen how the questions were asking and just gone from there. There's obviously some method to the order they ask the questions. So my advice to you is, if you're using this to study for a test, don't overthink a question. Hopefully you've come prepared for the test. The parts of the question will usually kind of take you through step by step through the entire question. So don't overthink it. The simple answer is usually the right one. Hope this helps. Thank you so much. Bye.